Perfect. Thank you, Molly, for the introduction. And I will go ahead and share my screen. So let me do this. All right, this should be good. All right, let's go ahead. All right, good morning, good evening, good afternoon to anyone who's joining virtually. Thanks for coming to attend my talk. I'm pretty excited to be talking about two topics that are near and dear to my heart today, and hence the title of my talk, Living the Cloud Agnostic Dream with Event-Driven Architecture. So my name is Tamimi. I'm a developer advocate at Solace. Feel free to reach out to me on Twitter if you have any questions. But let's go ahead and kickstart this. So before we delve into the meat of the talk, let me tell you about what driven architecture is, and it's also known as EDA. So you're going to hear me saying the word EDA quite a few during the presentation today. So in a nutshell, event-driven architecture involves asynchronous communication between applications via publishing and subscribing to events over an event broker as a mediator using a messaging protocol. So as you can see here, there are producers that are producing events and subscribers that are subscribing to events. And any event could either signal a change in state or an action or command. And one thing to know about events that they are immutable. So now that we know kind of the basic concept that is fundamental principles, what an event-driven architecture is all about. I want to delve more into the benefits of using an event-driven design. Why would we want to use an event-driven architecture? What are the benefits of using an event-driven architecture? First and foremost, coupling. EDA allows to break down the old school point-to-point interaction. So let's assume that you have a microservices or applications. You want to have point-to-point communication. It's pretty simple when you have a point-to-point application, when you have a small number of applications. Once you start to increase the number of applications, the number of connections scale linearly with the number of applications. As you can see, things could get quite messy once you have so many applications involved and you want to have point-to-point communications. With an EDA approach, you can have the decoupling of your system and avoid this point-to-point mess, what I'd like to call it. Second, having a reactive infrastructure where data is only sent when requested. So for example, let's say they have a microservice that is constantly pulling and asking the service, okay, are you ready? Are you ready? Are you ready? And then the back-end server would send a response back saying that it's ready. So this is a common use case where if you're using a REST-driven system and you're constantly polling, there's a constant polling using REST APIs for the server. Alternatively, you can have a reactive system with EDA where you just subscribe to topic ready, and once your system is ready, publish that topic and you will receive it. So your microservice or your infrastructure will become more reactive to business needs and customer needs. Third, scaling. Let's take the polling example I was talking about earlier and scale it massively. So now you have multiple different microservices, applications that are constantly polling your backend server. Alternatively, what you could do is you could have subscriptions to the ready topic, and once ready, all the different microservices that you have will receive the ready state. Lastly, resiliency. So let's take a use case where you have publishers that are bursty publishers. They're publishing bursty events, and you either have a slow subscriber or you get errors in a subscriber. The queuing mechanism, the queuing and the buffering mechanisms that is provided by an EDA or your underlying message broker allows for resiliency. So let's take, for example, a Black Friday event or tax season where you get these spikes of bursty data. You want to have your system as resilient as possible, and you want to make sure there is some sort of shock absorbing mechanism in your system. So now that we talked about kind of very high level, scratch the surface and one of the benefits and advantages of the EDA, let's jump into a real world use case on where EDA could be used. And in this use case, I'm going to be talking about a retail use case. So Let's assume that you have mobile applications, point of sale systems, and an e-commerce websites. They're all producing and generating events. These events could either include stock inquiry, new orders, return, shipping inquiry, and they're constantly publishing these events. And on the other side, you have other microservices, such as a finance microservice, warehouse database, customer service that consume these events and react correspondingly to the different kind of events. And these events will trigger some real-time responses that are generated as a subsequence of this events. Now, how would you implement such a use case, or an e-commerce, let's say, or retail use case? If you want to do point-to-point connection between your producers and consumers, that will get very complex, as what we saw earlier. So having an event-driven approach for your use case enables a decoupling of the applications, and there will be a brokered communications and interaction between the different microservices that are involved in your use case. All right, so now that we talked about EDA, what it is, the benefits of adopting an EDA, an event-driven architecture design, and gave a real-world use case, let's talk about the challenges that are associated with EDA. Just like any architecture that you choose, just like any system, there are benefits and drawbacks. And with event-driven design, there are so many different challenges that are involved. Some of the challenges, for example, go ahead, get my pointer in here. The knowledge and the skills of your team. Like, how do you make sure that your team has the right knowledge and skills to understand EDA design? Topology visualization. You know, your underlying infrastructure and architecture could increase in complexity. How would you visualize your underlying topology? You want to document your design, whether you have the schemas, the topics, the applications, different environments. Some of the very common challenges that I've seen in this industry is the translation and interoperability. Sometimes you would have different microservices, different applications that are communicating with each other using different languages, different messaging protocols, and different standards. How do you connect these different applications in your event-driven architectures? Collaboration between different team members. So those are kind of like some of the many examples or many challenges that are involved in an event-driven design. But today, because of the topics that we're going to be talking about, I will be focusing on one challenge, which is the distributed environments. If you have a multi-cloud, on-premise, or hybrid deployment of your microservices, of your systems, of your architectures, how do you achieve an event-driven design? So let's imagine a world where events move freely between on-premise and cloud services, where you have public and private clouds, where you even have legacy and new applications. You have IoT devices and different microservices. They want to all communicate with each other, and they're using different messaging protocols. Let's say one is using MQTT, one is using other proprietary messaging protocol or AMQP, and they're all using different programming languages. There are a lot of moving parts here. How do you build a resilient system that scales and allows for the flow of data freely between all the different moving parts? And today I'm going to be focusing as well on the cloud aspect of your event-driven architecture system. And you know, there are a lot of benefits to using cloud-provided services in your event-driven design, and it is super beneficial to have a cloud component in there. But again, you know, I will delve more into why would you want to use cloud with your EDA services. Let's step back here a little bit and kind of say, you know, in any system that you use, and when you try to incorporate a cloud aspect in your design, there are a lot of benefits to this. Some of the reasons to adopt cloud services in general is you can use the cloud provided services such as machine language, natural language processing. These are some of the services that are provided by cloud provider, whether you're using AWS, GCP, or Azure. They all have different services that they provide. You want to offload compute resources to cloud services. You want to scale your system, let's say by leveraging the scaling features in your cloud system. And you want to be closer to your data sources and sinks. Sometimes you have a use case or you work in an industry where the interaction is very time critical, and you want to be as close as possible to your data sources or your data sinks to reduce the latencies. So someone might look at this and say, all right, I can use one cloud service, and I could implement my event-driven architecture that is supported by this one cloud provided service. But the title of my talk is Adopting a Cloud Agnostic Approach to Event-Driven Architecture. Why would we want to adopt a cloud agnostic approach? And again, this is another kind of things that I want to talk about is benefits overall for adopting a cloud agnostic solution. Why would someone want to adopt a cloud agnostic solution? First of all, having a hybrid deployment. Don't put all your eggs in one basket, and don't depend on one single cloud provider. So if some of you might remember some of the outages that happened with cloud providers. So if you are depending on one particular cloud provider for your EDA implementation, if an outage occurred for that cloud providers, your whole EDA system or your underlying message broker in that EDA system is dependent on this one cloud provider. You want to avoid vendor lock-in and practice cloud arbitrage. And I'll talk more about what cloud arbitrage is in a minute. Sometimes you would have some political and customer requirement restrictions that requires you to use one particular cloud service over the other, or you'd go to some geographical locations or some countries that will not allow you to use a particular cloud service provider. Then if that's the case, you have to think about how do you adopt to different cloud providers and become cloud agnostic. Sometimes you would have geographical restrictions. You want to be as close as possible to your data source and data sink, and the cloud provider of choice that you chose to build an EDA system may not have servers or interactions closer to your data source and sink. I mentioned earlier cloud arbitrage, and a note on what cloud arbitrage is. So in a nutshell, cloud arbitrage is the process of comparing multiple cloud vendors against different factors such as performance, pricing, and overall capabilities, and then move your workload to platforms that best meet these needs. One of the advantages is you can save money, but also some of the things that you can get from cloud arbitrage is truly get the best performance for your use case, or get the best pricing, or get the capabilities. Let's say that you're using AWS for machine language processing, and using Google Cloud services for other provided services that GCP is better than other provided services. But then the question comes in place is, how do you do workload migration? How do you move your data between different cloud providers and have the data movement piece to become cloud agnostics? If you want to adopt an event-driven architecture, what are the tools out there that are cloud agnostic? You should ask yourself, all right, eventually in my roadmap, I want to be cloud agnostic. What are the tools in an event-driven architecture system that are cloud agnostic? And how do I move the data between different clouds? So assuming let's say that, I understand that the importance of a cloud agnostic implementation and the importance of event-driven architectures, the benefit of event-driven architectures when it comes to cloud interactions. How can I adopt this cloud agnostic implementation with event-driven architecture? And this is where I would like to present to you the concept of an event mesh, and put the slide in particular to kind of show, event mesh and cloud agnostic is a modern love story. If you want to adopt a cloud agnostic strategy to implement an event-driven architecture system, event mesh is your key. So what exactly is an event mesh? I want to kind of highlight the idea of an event mesh through this slide. Is, in a nutshell, an event mesh is a network of interconnected brokers. So you would have many brokers involved in your system, whether you have on-premise brokers, you have brokers that are message brokers that are deployed in different cloud providers, or you can even have your own private cloud and you want to deploy a message broker in there. And then comes the question of how do you stream the events and the data between different microservices in different form factors of deployment, whether you have on-premise, public cloud, or private cloud, using different messaging protocols and different programming languages. So one key concept of an event mesh that I'm proposing here that you have to know about is that the data does not flow unless it's being requested. So the brokers that are involved in this event mesh, the network of interconnected brokers, they manage subscriptions, and the key is to dynamically route data if desired. So this is one way to become more efficient with your use of bandwidth costs. So let's say, for example, these microservices, they only subscribe in your private cloud. They only subscribe to a particular set of events. They will only receive these events, and these events will flow into the system. And the key here is not to have all the events in your event mesh flow to every broker. The events will only flow upon requested dynamically. This goes back to the concept of cloud arbitrage that I mentioned earlier, where you just want to move your data to the cloud provider of choice. And they're only particular data. So let's say that I want to have a machine language or natural language processing service that is provided by AWS. I will only want to attract the events that are involved with this and not attract all the events in my event mesh. So no matter what cloud you're in, and another advantage of having this kind of event mesh approach is no matter what cloud you're in, you get to use the same messaging API underneath to query your data and interact with your data. For example, you will not have to rewrite your messaging logic in a cloud-specific service. So assuming that there is an EDA solution for AWS, EDA solution for Google Cloud, and EDA solution for any other kind of cloud, if you were to use that EDA solution for that cloud, you are locked into using the APIs for that particular solution. So, I hope this slide in particular leaves you with an idea on what an event mesh is, how you can approach an event mesh, and the benefits of doing an event mesh. So let's go back to our Imagine a World use case. And let's say that you are a supply chain company and have like a real world use case where ships are receiving and publishing messages using a lightweight messaging protocol, for example, MQTT. You have your IoT devices in the warehouse. They're publishing status information in your warehouse. You have on-premise microservices that are subscribing to corporate specific events. And you're routing data between different cloud providers. And data only moves in the mesh when requested, saving on bandwidth cost. So here's a little typo in here. But what I really wanted to highlight in this and kind of wrap up the talk in that, and I really want to have some time for Q&A, is the idea of an event mesh where you would want to use an advanced message broker that supports the implementation and adoption of an event mesh. And this advanced message broker allows for the dynamic movement and the dynamic translation of data in your event mesh. So the reason why I always talk about this kind of supply chain example and I bring this up is there's a lot of moving parts that are involved to adopting an event mesh and event-driven architecture. And before taking a stab at adopting a tool, let's say any particular tool to implement your event-driven architecture, take into account what are the different use cases that you want to do. So examples of supply chain companies that have really adopted and benefited from an event mesh. You have Unilever, for example. They use the concepts of event mesh in supply chain management. IKEA uses an event mesh to keep track of inventory worldwide in different, and they're having like a cloud agnostic solution and approach for this. And there's other different kind of industries that use it, whether you're in the retail industry, supply chain industry, financial industry, capital market industry, aviation industry, there's always place for event-driven architecture systems that would increase the resiliency and efficiency of your solution, and also allows for the implementation of a cloud agnostic approach using an event mesh. So that's what I have for you today. I really wanted to scratch the surface on what event-driven architecture is all about. How do you benefit from a cloud approach to adopting an event-driven architecture, and what are the advantages of having a cloud agnostic approach for deploying and adopting an EDA design. And most importantly, taking an event broker, an advanced message broker that can support an event mesh, message protocol translation, and dynamically routing your messages between your different producers and subscribers. So finally, if you want to kind of learn more about event-driven architectures, learn more about different use cases, about event mesh, about the cloud adoption of event-driven architecture, go ahead and scan this QR code. And upon scanning this QR code, you will go to the Solace community. You can find me there on the Solace community. Send me a DM, post a question on the community, read what other people are talking about in the community. There's a lot of experts in the Solace community that talk about event-driven architecture design, whether it's Solace specific or just general in EDA. So go ahead, scan this QR code and register for the community. Or you could also follow me and reach out to me on Twitter. And that's all I have for today. So I will jump back into the chat section and kind of see if we have any questions. And I will stop sharing my screen. All right.